Okay, 43 says find the area of the region bounded by the graphs of these equations. So if we graph 5x squared plus 2, x equals 0, x equals 2, and y equals 0. So y equals 0 is the x-axis, x equals 0 is the y-axis, x equals 2 would be a vertical line that always has an x value of 2. And then over here, I know what x squared looks like. Adding 2 would just shift it up 2, and putting a 5 here would be a vertical stretch. So it's going to be like a parabola, but it's going to be a little steeper. Something like that. And our job is, if I read the directions again, find the area of the region bounded by the graphs of the equation. So they want to know how much area is trapped in these 4 lines. So really, what we're doing is we're asking ourselves, what's the area under the curve between 0 and 2? Those are the x values I'm looking at. Under this curve, which is 5x squared plus 2. So now it looks like the other questions that we've already done. But integration has quite a few applications, but right now the application that you need to always ask yourself is about area under the curve. So if we sketched all those, graphed it in, now we've got it set up this way. So raise the power by 1, divide by the new power, raise the power by 1, divide by the new power, plug in a 2, then plug in a 0, subtract those values, and it looks like we should get 40/3 plus 4, or 52/3. And I'm going to slide over to my calculator and throw that in real fast. I have not been practicing integration much myself, so it's always kind of nice, especially if you're used to doing it. It doesn't take very long. Okay, and that answer is a fraction, 52/3. Confirms all my arithmetic was set up correctly. Okay, anything more specific about 43 for those of you that needed help on this one? It doesn't seem like it's an integration question because it ends up being the area under the curve. That's how you can set it up and solve it.